Okay, we're going to go ahead and get started. Welcome everyone to our Database Foundations in SQL lecture. My name is Isaac. I'll be the lead instructor for this lecture. A couple notes to mention before we start is this lecture we are not going to take any questions. So if you do have questions that pop up along the way, feel free to go ahead and just email or Slack message those to me after the lecture, and I'll be glad to clear anything up for you. As well, it's important to take note that we are recording this lecture. So in the event that you are watching and you didn't catch something, you can also view the lecture. We're going to post the recording on our Slack channel once it's done. Okay, so go ahead and let's get started. Like we mentioned, the main topic for today is database foundations in SQL. So before we get, actually going with our database and writing different commands, let's go ahead and talk about what is SQL. And you're going to hear it pronounced a couple different ways, SQL or SQL. But the basic acronym for it is the structure query language. Okay, so and then the database type is a relational database management system. Okay, so what is a relational database? Okay, so it's a database that is organized and structured to relate stored items of data. So you can think of this in kind of an aspect like Facebook, right? Every time you log into your Facebook account, you are one user out of billions. And you have specific posts, okay? So there's user data and then there's post data, okay? And Facebook's able to relate these two pieces of data together every time you log in. So it only displays your information and not everyone else's. So that's kind of the underlying concept of a SQL database is we're able to relate these different stored items and create different relationships based on what we need in our application. Okay, so that's a broad level overview of SQL. And then let's talk about the different open source variations available. Okay, so there's several different branches, if you will, versions of SQL that have been built throughout the years. Just to mention, we've got MySQL, PostgreSQL, SQLite, and a couple others. So for this course, we're going to actually be using SQLite. So feel free to explore the others if you want, but we're just going to concentrate on one for the moment. So to really, dive in and start using any kind of technology and programming, the best place to start is always the documentation. So let's go ahead and let's explore what that looks like. We're going to go to SQLite.org. Okay. And as you can see, they've got documentation. And this documentation has everything you need to know about all the different commands and queries and everything you can use in SQLite. Okay, so if you're wanting to know something, this is the first place you should go. Then, of course, you can look at Google and Stack Overflow as well. But documentation is always up to date. So that's usually the best place to look. Okay, so next, let's go ahead and let's create our first database, okay? And today, we're going to be creating something called an embedded database, okay? So this kind of, there's actually several different kinds of ways you can set up databases in programming. Some databases are set up in the cloud. Some are set up between, data farms, multiple machines. Some are set up on your local machine. Okay, so that's actually what we're going to do today. We're going to create an embedded database, which is just going to be a file stored on our machine. It's going to read from that file and add and update and delete accordingly. So let's go ahead and first create that file, which we're going to use for our embedded database. So I'm going to start off by creating a directory, and we'll call this directory mydb. Then let's open our command line interface and change directories into my DB. Then I'm going to open this up in my text editor. And inside my text editor, I'm going to create a file called my.db. So just wait for, there we go. Go to the root directory and we'll say my.db for the file name. Okay, so this is what it's going to write to. So now we need to set up our graphic user interface, which we are going to use SQL Electron for this course. Okay, so if you haven't already installed it, you'll need to install it if you're going to follow along. If you don't know where it is, you can, of course, look in the Coder Camps lesson, but then you can also go to SQL Electron .github.io, and then as you can see, you can download the GUI here. Okay, so this is what we're going to be using. This is the tool which we can view our data and we can also manipulate it. So you can look at this very much like a text editor for coding. This is somewhat the same kind of concept for our database. So once you've installed that, the next step is we need to connect our SQL Electron with this database. Okay, so let's go ahead and let's open up SQL Electron. And let's see, here it is. Okay, so it's going to boot up. Okay, and as you can see, we have no databases set up at this time. So let's go ahead and connect to the database on our desktop right here. So we can say add, and then for the name, let's just call it MyDB. For the database type, like we talked about, there's different versions you can use, and we're going to use SQLite today. Now it needs to know where is this database located. So the easiest way to do this is let's just open up our text editor and right-click on the file and then copy the full path. And now we have the full path on our clipboard. We can simply paste it in accordingly, and now it's pointing to our database file. So we're going to save this, and now we just need to hit connect, and as you can see, it's connected to our database. Okay, so from here, let's go ahead and let's talk about the anatomy of a SQL database. Okay, so there's three main components that make up a relational database. Okay, we've got tables, we've got rows, and we've got columns. Okay, and as you can see, it immediately generated an empty table section because this is the core component that makes up our relational database. So oftentimes when you think of relational database, you can think of something like an Excel spreadsheet. Okay, so by definition, let's just kind of walk through what is each one of these components and how do they interact with each other. So a table is a subcontainer for our data. Okay, so you can view it somewhat like the whole Excel spreadsheet. Okay, and then we've got columns within that table. Okay, so you can view it very much like the columns going down our Excel spreadsheet. Different categories such as name, age, weight, you name it. And then we've got rows. Okay, and a row is a separate record. So each separate record, each line we've got going down, that is our row. Okay, so it's not very complex. A lot of us are actually already kind of familiar with the concept and the structure from using spreadsheets like Excel all of our lives. So don't overcomplicate it. It's really not that crazy. So let's go ahead and start off by talking about how we can create each of these. We can read the data that we've inserted, and we can update and delete it as well. Okay, so let's go ahead and let's talk about first tables. Okay, so tables, as we mentioned, is like the whole defined spreadsheet. It's the very much the model. Okay, so what we want to do is we want to construct this blueprint so that all the data saved under this table matches the same kind of structure. So let's go ahead and start by creating our first table. Okay, so let's create a users table. And whenever you run your query syntax, you should always use capital casing for the built-in commands, and then use lowercase for arbitrary variable values that we make up and we insert ourselves. So for example, if I want to run the create command for table, I would simply say create table, and then I'm going to call this table users. And then what I need to do is I need to pass in the structure of this table. Okay, so let's say I just want maybe two string properties, one for first name and one for last name. So what I could do is I could pass in a first name property here, and I can make it a max character amount of 50. And let's do the same thing for our last name here. Okay, so now we just need to push the execute button here, and it's going to run this query. Okay, so oh, I forgot the yeah, as you can see, this has a matching parenthesis here. Okay, so let's execute this again. Okay, so as we can see, the query was successful. So now inside of our tables here, we have users, and as we can see, the structure for users is first name, last name, and it has the data type that we set at creation. So this is how we can create a table, and we can create many tables as we want for a specific app. So like I mentioned a minute ago, with maybe a social media app, you would have maybe a posts table and then a users table. Maybe many others, maybe a comments table as well. It really, you could really go all day with what you do. It's really, depending on what you need for your app, but we're just going to keep it simple today, and we'll just have a simple users table. Let's go ahead and mess with this table a bit to kind of get used to how it works and how we can change its values. Okay, so we've created our somewhat blueprint, but we haven't actually created any records. Okay, there's no actual stored data. Okay, all we have is somewhat of a blueprint for the data of how it's supposed to be. So let's go ahead and let's insert our first record, and these records are referred to as our rows. Okay, so our rows, we just have to specify what column values we want to insert. So here's how we can do this. Okay, we're simply going to insert the users with our values. Okay, so we'll say insert into, and then we'll target the users table, and then we will pass in the following values. So the first value, let's make my first name, and then the second value, let's pass in my last name. Okay, so now we have this query running. Let's go ahead and execute. And as we can see here, it says it affected one row. So now in SQL, what we can do is we can use our select command to view and query certain collections of data. Okay, so let's go ahead and let's do that by saying select all from, and then we'll just target the users table. Okay, and as we can see here, we're given the one row we've created, and it's sectioned off into the separate categories and the values that we assigned when we inserted this row into the table. Okay, so as you can see, looks very much like an Excel spreadsheet, and we got the columns running down for this specific row. So the beauty of this, kind of setup is we can create as many, rows as we want, have thousands, hundreds of thousands of them, and they're all nicely organized for us. Okay, so let's go ahead and let's explore what happens when we try to create a row that doesn't match the specific table structure which we have set up. Okay, so for example, if we were to say want to create another row. We would say insert into, and we would target users, and then we would pass in the values. Okay, so let's say, you know, I passed in my first name again, and I also did my last name again. But then let's say I want to pass in my age. Okay, so I passed in my age, and let's see what happens when I try to execute this. Okay, as you can see, I get this error, and it's telling me that there's, you know, only 2 columns, but you're trying to apply 3 values. So this failed, meaning nothing was executed. So now if I go ahead and I select all from users, I can see that I'm still getting the same record here. It didn't insert anything because it will only accept data that is in the same format which we initialized it at. Okay, so it has to have, you know, just a first name, last name, and they have to match these data types as well. Okay, so that's the kind of strictness about relational databases is you have to follow the set rules in place, but it's also a good thing too because it makes it to where we're always in control of how our data looks and what's being thrown in our database. Okay, so let's go ahead and let's talk about how we can query the data in different ways. Okay, so if we come here, let's say, let's create another record. So we'll insert into users, and then we'll pass in the following values. Here we go. So let's say the first value is John, and the second one will be Doe, and then we'll go ahead and execute this query. And now if we select all from users, we can see that we have 2 rows instead of 1 now. And, you know, as easy as that, I just, you know, assign it the values I want and it plops right in there. Okay, so let's say I want to get a certain amount of records, okay? Because as I mentioned, in a, you know, actual live real running SQL database, you're probably going to have thousands of records. So if that's the case, sometimes you don't want to, you know, query all 100,000 of them. Maybe you just want the first couple records. Maybe the first 100, you know, who knows, but sometimes you have a specific number in mind you want to extract. So this is where we can use our limit keyword to perform this task. Okay, so all I need to do is I just need to specify a limit quantity. Okay, so I'll say select all from users, and I'll limit it to 1. Okay, so when I execute this, as we can see now, instead of just getting all records, I'm actually only getting 1 record as specified by my delimiter here. Okay, so that's how we can accomplish filtering by quantity. So let's talk about how we can query by column. So as you can see, we've got, you know, first name and last name columns. So let's go ahead and let's target just one of these values instead of extracting every single one of them. Okay, so let's discard this, and let's go ahead and let's select just the first name from users. Okay, so we'll say select, and then instead of saying all, we will target the column we want to select, and then we'll say from users. Okay, and now we just need to execute our query. And now, as you can see, it returns all users, except this time it only returns the data we want. Because as well as having many rows, some of your rows can have a ton of columns. I mean, again, you think of something like a Facebook account and how much data is comprised around just one user. Sometimes it's really like searching through a needle in a haystack if we're trying to just look at every single column and you know, kind of digest it that way. It's not really efficient. So this is where querying by a specific column is useful, because we just get the data we want, not the data that is there. So let's go ahead and let's talk about how as well as filtering by column, we can filter by a specific set query expression. Okay, so let's go ahead and let's see what that looks like. So what if I want to target a user by the first name of Isaac? Okay, let's say I know who I want to target, but there's hundreds of thousands of rows, and I don't want to scroll through all those. I just want to search for one single record, and I, I want it to match this expression where the first name equals Isaac. Okay, so let's go ahead and let's throw that in here. Okay, so we'll say select all from users, and then we throw in our where keyword, and we set up our specific query. So in this case, I'll say where first name equals Isaac. Okay, so when we execute this query, as we can see, instead of abstracting all records, it only abstracts the records which match this filter. Okay, so this is one of the most common kind of queries you're going to be running using a relational database, because oftentimes you're searching for specific data. Most of the time, it's very rare that you just ask for all data. So this filter, this where keyword, is a highly practiced keyword. So get familiar with it because you're going to be using it a lot. Okay, so moving forward, let's talk about how we can also order data in a specific way instead of receiving all records in whatever order that they were inserted. Okay, so let's say, for example, I wanted to order all records, by my last name. Okay, so let's go ahead and let's say select all from users, and then we'll say order by, oops, and then we just have to specify the specific column. So let me say, I'll say first name right now. Okay, so we execute, and as we can see, because I is before J, it executes in this specific order. But if I instead put in last name and run my order by, I can see because D is before G, it actually sorts it and puts this row above this one instead. So if we're trying to order records, it's very useful in chronological situations, last name kind of alphabetical grouping. You're going to be using this keyword a lot in that regard. Okay, so moving forward, those are some of the basic query functions of ways we can look at our data, and also we've learned to add data to our tables. So now let's talk about how we can update that data and change its current state in our database. Okay, so let's go ahead and let's say that when I signed up, maybe my autocomplete or something I had saved my last name to Gray, but it's actually Jones, and I need someone to update about my database. Okay, so let's go ahead and update the last name from Gray to Jones accordingly. So let's go ahead and let's target the specific table we want to update. Okay, so we're going to use the keyword update, then we're going to target users. And then from here, let's go ahead and use the set keyword to set the value of last name, and we'll make it equal to Jones instead of Gray. And then let's go ahead and let's target the specific row we want to update. So we can use our where syntax and target the row where the first name equals Isaac. Okay, so when we execute this, and then we run our query to view everything in our users table, we can see that now my last name is Jones instead of Gray. And that's how we can, perform a update inside of our database using the, set keyword. Okay. So moving forward, let's talk about how we can remove data and delete it from our database. So if this is the case, let's go ahead and let's delete one of our two records. Okay. So delete works very similar to update in the way that we are going to simply target the table which we want to delete from, and then we need to pass in a filter to target it down to specific set of rows or a row itself. So what I'm going to say is delete keyword, and then we'll say from users. Okay, so we'll target the users table, and then we'll use the where operator, and we'll say where, let's maybe say the last name equals Jones. Okay, so now when we execute this, we can see that after the result in our users table is that we only have one record, one row, instead of the two we had just a minute ago. And that was a result of our delete query. Okay. So by now we've actually explored how you can create, read, update, and delete data from your database. And this is actually a very big programming concept referred to as CRUD. And it's just the acronym for the 4 operations that I just mentioned. But it's the very core and heartbeat of any website and application running right now. When you think about the internet, there's only really 4 operations that are ever performed. So knowing these can be vital to your success as a programmer, because you're not going to be able to get by knowing just 1 or 2. You're going to need to know all 4 to create fully front to back applications that are on a modern standard too. Okay, so moving on from CRUD, let's talk about manipulation functions. Okay, so as you notice, we have a bunch of keywords that are built in to SQL. But just like these keywords, we also have specific manipulation functions that are built in that allow us to format and rearrange our data in a different order based on our specific need at the time. And this is very useful in instances where maybe we don't know what the incoming data looks like, and we need to make sure that we put it in a certain format before it's officially saved. Okay, so let's explore what these different manipulation functions look like in SQL. Okay, so the first one let's talk about is substrings. Okay, so the substrings, it returns characters through the end of the string based on certain quantities that we pass in this operator. Okay, so for example, let's go ahead and let's say select substring, and then we'll go ahead and we'll pass in my name, and then for this value we'll pass in index of 0, and then we will start at this 3rd position. Okay, so what this is going to do is it's going to start here, and it's only going to return these 2 values because of the quantity of 3 that I passed in here, which is 3 spaces from the right. Okay, so substrings come in handy when we're just trying to select positional characters in data. So let's go ahead and see what this looks like when we execute it. So as we can see, we're only returned the values which we selected within our quantities here. Okay, and again, this is what's known as the substring manipulation function. So another one you're going to run into is sometimes users are going to pass in different casing. Some will do all caps, some will do lowercase, and some do both. So a lot of times in your database, you want one nice clean format. You don't want like mismatching rows. So it makes sense to make everything uppercase or lowercase sometimes. So let's go ahead and explore what that looks like. So if we say select, and then we use the upper keyword, then we can just pass in the specific data we want to manipulate. And from here, when we execute it, we can see the result is the capitalized version of the string that was passed in to this manipulation function. Okay, so in the same context, we can do the same thing with lowercase. So I could simply say select lower, and then pass in maybe a capitalized version of my name. And when I execute this query, I can see that it's returning the value of the lowercase version of the string that was passed in. Okay, so again, these are useful for when you want to format your data under one kind of casing, which is a very common constitution in programming. Another common manipulation function you're going to run into is rounding. For example, some companies might not want to count, the extra cents or, percentages. Maybe they only want the one flat, dollar amount that was received. So in that case, you would use the round keyword to round your values to your specific desired value. So what that would look like was we would specifically just pass in select round, and then we pass in our value. So maybe it was $2.50. And then when we execute the query, we can see that it rounds to the nearest integer, which is 3. Okay, so these are 3 or 4 of some of the more common manipulation functions you're going to see in SQLite. But remember, there's hundreds of different things you can do. This is just the tip of the iceberg. So I encourage you to visit SQLite docs and really go over everything and see just all the ins and outs of what you can do with it. And I think you'll see that this is a really powerful kind of technology that will make your programs really, really great. So going forward, let's go ahead and let's talk about an important concept called database keys. Okay, so as we mentioned at the very beginning of this lecture, a relational database is a database that is organized to create relationships between stored items of data. Okay, so now comes in the concept of how we relate stored items of data, because this relationship doesn't just happen on its own. We have to create the relationship. But this is a good thing because we have customized control of what we want. Okay, so let's go ahead and let's explore the various types of ways we can set this up. So the first thing we need to talk about is integer keys and primary integer keys. Okay, so every single row in your tables should have a primary integer key. And this is very much an ID. It's something that's unique. It's going to separate all your rows and records. So if you want to just target that specific one, you can. So for example, some 2 rows might have the same username. Okay, so if they have the same username, then we can't query by their username anymore if we want to just target one of those 2. So this is where a integer primary key comes in handy, where it's completely unique to that row, and we can select individual items based on that key. Okay, and another database key I want to mention is something called a foreign key. Okay, so a foreign key is very much a way of tagging a specific table and relating it to another table. Okay, so it's usually the integer key of one table that is the foreign key of another, and that's how they're related. So enough talking, let's go ahead and see what this looks like under the hood. Okay, so to get started, let's go ahead and create a new table. Okay, in this table, let's make it our customers table. Okay, so let's say create table. We'll call it customers. And then let's go ahead and give it a name property, and this will be max value of 50. Let's give it a customer ID value. And what we're going to do is we're going to make this our primary integer key. Okay, so I'll say var character here, and then we'll say integer primary key. All right. So from here, I just need to seal this up. And now it's going to create a table which is going to have a name column as well as a customer ID. So when we execute this, we can see if we look in our customers table here, they have each of the data types just as we assigned, and they are set up and ready to start getting values inserted. So now that we have our customers table set up, let's go ahead and let's insert some values into these customer tables. Okay, so let's do the first value or the first record. Let's make it just a name and an ID. So we'll say insert into customers, and then the values which we are inserting. The first one will just be my name. And then the second one, we'll make my ID the number 1 because I'm the first record in the customers table, okay? So let's go ahead and execute this query. It affected 1 row. So let's go ahead and let's do the same thing, except let's insert a different customer with a different value for their ID. So we'll insert into customers, and we will take these corresponding values, and let's make this first value, let's make it John, okay, and for the ID, let's make it 2, okay. So now we've executed a couple insertions. Let's go ahead and let's view all of our data in the customers table. Let's see what that looks like. Okay, so right now we've just got a couple different customers with a couple different primary keys. Okay, so now let's go ahead and let's create an orders table, and we're going to use the foreign key of the orders table to relate to the primary key of the customers table and create a relationship between orders and customers. Okay. So to do this, let's go ahead and start off by creating the orders table. So we'll say create table orders, and then we just need to pass in specific values. Okay, so let's start with order ID. Okay, and this is going to be the integer primary key for this specific table. And then let's go ahead and let's pass in a customer ID, okay? And this will be our foreign key to relate our tables of data, okay? And this is simply going to be a variable value, okay? So let's say var car 50, okay? So now we're creating this orders table with these 2 specific keys. Let's go ahead and execute this. And let's go ahead and insert some values inside of the specific orders table. Okay. So we're going to simply say insert into orders, and then the values that we're going to pass in are going to be 1 and 1. Okay. Oh, can't forget my E here. Okay, so we'll execute. This was successful. So let's go ahead and let's do this a second time. But instead of inserting these values, 1 and 2, let's insert 2 and then the number 50 just for a random value. And let's execute. Okay, so now we've inserted a couple values into our orders. Let's go ahead and let's view what that looks like. inside of our interface here. Okay, so we execute and we can see we've got a couple orders and the customer ID. Okay, and as we can see with this foreign key, I've set it up to where this customer ID is actually matching the customer ID from this table. So as we can see, if we look at customers, the customer ID for this customer is 1. And in the orders here for my foreign key, the value of customer ID is 1 as well. So this is where the relationship is created. This is where I can use queries now and filters to match these specific values and perform the various relationship operations that I'm looking for. Okay, so now let's go ahead and let's talk about now we've created this relationship between these two tables, how we can use that relationship to populate multiple parts of data in one single query instead of having to perform 2 separate queries on 2 separate tables to get that same result. Okay, and this process is something called a join. Okay, and a join in SQL, again, is a way of populating data from one table to another. Okay, so let's see what that looks like under the hood. Okay, so for our first join, or more specifically, let's talk about the different kinds of joins. Okay, because there's more than one. And today we're just going to be going over inner joins and outer joins. Okay, and inner joins is just select specific records. Sorry, it just selects specific records matching our query, whereas an outer join gets all records if there's a match on the right or left table. Okay, so we've got a couple different kind of differences between these two joins. So let's see what this looks like in action. Okay, so first example, let's do an inner join. Okay, and so for this inner join, let's go ahead and let's get all the orders that are related to the customer and join that information together. Okay, so what we're going to say is select all from customers. Okay, and then we're going to use the inner join keyword, and we're going to join customers, and we're going to use the on keyword to specify when to join the data, and we're going to say when the orders dot customer ID equals customers dot customer ID. Okay. So that's it. That's all we have to do. We just basically tell it when to join the records. When we execute, oh no, customers dot name. Okay, so let's see here. Oh, because yeah, I need to do customer dot customers. Let's see here. Yeah, customers dot customer. There we go. Apologies, folks. Give me a second. Let me double check my work here. I'm selecting all from customers. Oh, you know what? It's from orders. I wanted, yeah. Here we go. No such column. Customers dot. Okay, I'm joining customers on orders where the customer ID is equal to customer.id. Okay, there it is. Sorry about that, folks. Okay, so uh, as you can see, I'm telling it, find all my orders. And when you find an order where the customer ID on that order matches the customer ID on the customer order, then join all of that data together and return it to me in my query results. Okay? So this is an inner join. Okay, we're joining the inner table values because we got two tables and we're using that customer ID to relate their values and get all of the values from both tables in a single query versus two queries to each separate table. Okay, so this is the kind of a beauty of a join. So that's an inner join. Let's go ahead and let's see what an outer join would look like. Okay, so let's go ahead and let's select all from orders. And then we're going to perform, let's do a left outer join. So we'll say a left outer join. And then we're going to do same thing for customers on orders dot customer ID, where they equal customer dot customer ID. Okay. So as you can see, with our left outer join, instead of returning just specific records, it returns all values that match on either the left or right table. Okay. So as you can see, only one specific value matched, so it returned those values. Okay. So this again is an outer join, and it's how we can populate, multiple values if we want more than just one specific record. Okay, and then there's other kinds of joins as well. That's not limited to these few we're showing you today. So feel free again to go to SQLite's documentation and explore all the different kinds of joins that you can perform to obtain different results. Okay. So let's talk about how we can perform or create reusable commands to where we don't have to constantly type in the same query command over and over and over again. So for example, you might have noticed that every time I make a change, I'm having to say select from the specific table and return all values. And it takes a little bit of time to do every single time, type that out. So instead of typing it out, I'm going to create something called a view. And a view is a single command which is going to act like a variable, and it's going to encompass a series of commands inside of it. And so I can run just that one line instead of a bunch of different lines and obtain the same result. Okay, so let's create a view for our join here. Okay, or let's do something simpler here. Let's just say view orders. Okay, so we'll go ahead and say, okay, we want to view orders. So we'll say select all from orders. Okay, and when we execute this, we can see it's returned everything. So instead of every time having to say select all from orders, let's go ahead and let's create a view. And let's call it create view. We'll call it get orders. And then we'll use the as syntax to assign what commands we want to run when get orders is queried. Okay. So as you can see, it successfully set that up as a view. So now all we need to do is we just need to select all from, and then we just need to say get orders. Okay. And as we can see, now it's returning the same exact result, except this time I only have to type in get orders. So as you can imagine, with long, complex commands, it doesn't hurt to comprise them and compact them into this single line, which you can use anytime you need, instead of having to write the whole thing over and over again. Okay, So let's talk about another important part of relational databases is something called a transaction. Okay, so a transaction is very much the concept of when you start a series of commands and end the series of commands, everything is either successful or it's not. Okay, and the reason we need this is because, as you can imagine, if we have one command that says add so much money to this person's account, and that command is successful. We have another command that runs that says add this much to another person's account, and that command fails. Well, then we would have an uh, inconsistent trace of data, basically. So because we never want that, we always want everything to succeed. We use transactions to automatically make sure that all of the operations were successful or none of them were successful at all. Okay, so we need this kind of two-sided logic. And again, this is referred to as a transaction. So let's go ahead and let's explore how we can create a small transaction in SQLite. Okay, so the first part about transaction is let's go ahead and use the begin keyword. Okay, so we'll say begin transaction. Okay, and then we need to specify what what operations we want to run. So let's go ahead and let's delete one of our customers. Okay, so we'll say delete from customers, and then we'll target where customer ID equals 1. Okay, and then we need to commit our transaction. Okay, we need to execute and make sure that everything goes through. So we'll simply say commit. Okay. As you can see, using these two keywords, I'm able to start and end a transaction. And this way, it will only commit the code or not the code, but the operations if everything was successful. Okay. So because technology can fail, because nothing's perfect, we want to expect the worst and hope for the best. So this is kind of how we can set this up with a transaction to ensure that operations are 100% or they just don't go through. Okay, so I'm going to execute this transaction. And as you can see, it said, 1 rows were affected. So now if I want to maybe see all my customers and see if, that indeed did go through, let's just go ahead and take a look now. We can see that the customer with the ID of 1 was deleted because we ran our commit keyword and it committed those operations successfully. So now let's explore how we can use something called rollback to basically null and void all the operations that were just performed to make sure that they roll back to their current state. Okay. So how we can do this is let's go ahead and let's set up our transaction again. So we'll say begin transaction. And then let's go ahead and delete from, let's go ahead and say customers. And we'll say where customer ID equals 2. And then instead of committing, we'll go ahead and pass in rollback as the keyword. And we can see now when we execute this, it affected 1 rows, but it didn't actually run this operation because I set up rollback to roll back to the previous state. So what I'm going to do now is let's go ahead and let's check out all of our customers, and let's see if it deleted that. So as you can see, unlike my previous transaction, because I used rollback, it didn't go through. It performed and then unperformed that action. Okay, so this is how we can undo mistakes if they happen, which they do all the time in database situations, because you can imagine you accidentally delete certain sets of data. It can really affect the operation of your application. So to kind of avoid that, you can use transactions to set up a little more strict kind of guidelines on what is ran when. Okay, so let's go ahead and let's take a look at a example of a real world transactions. When would this actually come in real play and maybe a real application? So let's go ahead and start off. Well, actually, before we do that, let's create a couple new categories of data. Okay, so let's create a account table. Okay, and with this account table, what we're going to do is we're going to create a couple rows for the different accounts, and then we're going to transfer money from one account to another. And using a transaction, we're going to make sure that all the operations are successful or that they just don't go through at all. Okay, so let's go ahead and create a new table. We'll call this one account. And then we'll pass in the specific values for this account. So we'll say account ID will be our integer primary key. And then let's go ahead and throw in a balance. And this will just be, let's just make it an integer value so we can perform mathematical operations as needed. Okay, so now we've created our table. Let's go ahead and insert some values into this table. Okay, so I'm going to say insert into account, and then the values I'm going to pass in. Let's see, the first one will make their account ID 1, and let's say they will have $1,000 initially to start. Okay, so we'll execute that query. And then the second account, let's make it an ID of 2, and we'll give them $0 to start. Okay. And now let's go ahead and let's check out all the data that we've inserted into our account. Okay. So as we can see, account 1 has $1,000 and account 2 has 0. So now we're going to set up a transaction to transfer some money from this account to this account, and it's not going to commit those changes unless everything goes through successfully. Okay, so let's go ahead and let's begin our transaction. Okay, so we will say begin transaction. And then we need to specify what we want to change. Okay, so let's update our account 1. So we'll say update account. We will we'll use our set keyword, and we will set our balance to equal balance minus 100. Okay, because we're transferring money from this account. And then let's target what specific account row we're targeting. So we'll say where account ID equals 1. Okay, and then we're going to follow the same suit with this second transaction here. Okay, and we're going to instead we're going to add $100 to this account number 2. Okay, so as you can see, we need both of these to be successful, because if only this one is successful and not this one, that is going to screw up our entire system. Especially for something to do with sales or payments, we need everything to always be evened and accounted for. So to make sure this happens, we set up a transaction, and that ensures that everything is successful or nothing at all. Okay, so I'm going to go ahead and I'm going to commit this transaction. And then let's go ahead and let's execute this. Okay, so as you can see, it's giving us a success message. So now we can go and we can look inside of our accounts. Oops. Okay, and as we can see, it's successfully transferred $100 from this account and added $100 to that account. And because we had our transfer or transaction set up, we didn't have to worry about any of these values not lining up. They're always going to be successful because our transaction is there as a safety mechanism. Okay. So that about covers it for today's lecture. Thanks again, everyone, for joining us. I hope you enjoyed it. Again, we are recording this, so keep an eye out on the Slack channel, and we will post it up there shortly for your viewing needs. And then, of course, if something didn't make sense during the lecture, please feel free to reach out to me afterwards, and I'll be happy to clear that up for you. Thanks again, everyone, and have a great day.